Hi there. I'm going to give you a tutorial about parsing non-tabular data using regular expressions to get CSV or tabular output. So first thing I want to do is show you this directory of files that we have in the NC package in the Exadata directory. We have this system file Exadata, comma. So let's start with the fread report.txt.gc first. Must work equals true. So there's the path to that file. Let's read it using read lines and see what that looks like. Oh, here we go. Let's read it. So we can't use up arrow here. Let's read it using read lines. And that's going to be, let's call it report vec, because that's going to be a vector of lines from that report file. So let's just look at the first few lines here and see what they look like. So in that report, you basically have somewhat CSV looking data. So here are the first 20 lines. Well, the second line doesn't look like CSV, but after the third line it looks like CSV. But if you go further on in the file, say to lines 1000 to 1010, you see that, well, the end of that first block is happening, and then we have this //2, and then what looks like some more CSV data. So the output of this bioinformatics program is not technically CSV, but it's got these CSV blocks that we might want to parse with some CSV reader, but we just have to parse those blocks out. So the blocks are delimited by these / things with these ID numbers starting at 1 and going up. So if we take a look at the other file in this data set, that's the info file. Let's take a look. Fread info.txt.gz. Let's call that info vec. And so let's look at just the first few lines here. So here, this file, you've got like some header. This is the standard out from the program, I think. And then after that, you have the authors of that program, which we can thank for the nice file format here. And these are not the most interesting lines. So let's go to the next ones. Lines 20 to 30. How about that? So here we start to get something interesting. Let's go all the way up to 40. So in here we start to see some information. Your alignment 1 has a certain chromosome, certain number of sequences, sites, discarded sites, processing, etc. Alignment 2 has a certain chromosome. So you see it's the same format every time. Alignment, then chromosome, etc. Right? And actually these alignment numbers, 1, 2 here, that corresponds to the / numbers that we saw here. So these are all the data for alignment number 1. These are going to be all the data for alignment number 2, etc. Right? So to parse these data using regular expressions, well, let's first focus on this second file. What we want to do eventually is we want to join these files together based on this alignment ID. But let's just take this one at a time. Let's just take a look at this info file, this info vec that we've read into R now. How are we going to parse that using NC? Well, we have this function called capture all stir. That's going to extract all of the occurrences of a regular expression pattern from a character subject, string subject. And here it's a multi-line string. That's fine. We'll just pass it in the whole info vec, and let's see what we get. And so what we're going to get, what we want to match is we want to match each one of these alignment blocks. So each one of these alignment blocks is going to look like this. Alignment equals, well, so here I'm creating an extraction variable called alignment. So actually before doing that, we actually have to match this a string called alignment. And then we have to match a digit. maybe convert that to an integer. And after that, after the alignment, it looks like there's 2 new lines. Then there's 2 tabs. Then there's chromosome. Then there's 2 tabs again. And then here we can call this the chromosome name. Yeah. So let's see if that works. For a first pass, we can evaluate that and see if that gives us something sensible. So indeed it does, right? So applying this regular expression here to that subject results in these 10 matches. So we see that the alignment varies from 1 to 10. The chromosome varies from scaffold 0 to scaffold 9. So one thing that you'll notice though in this code is that, well, we have a little bit of repetition. The repetition is the bane of any good programmer. So one thing that we've developed in NC is a way to avoid this repetition. This is a common pattern that happens when you're parsing these kind of files, where you see that here there's something that says alignment, and then you want to extract a column with that same name. Here there's something that says chromosome in the file, and here you want to extract a column named chromosome based on the data that occurs after that. So to do that, we've developed this function called NC field. So NC field, it's just a way of doing the same thing that we just did, but avoiding that repetition. So here I'm going to type alignment, and then I'm going to type space as a second argument, and then I'm going to type 0 to 9 plus. And so, actually we can also include as integer in here too if we want. And so this whole thing is going to be a replacement for these lines, for this line actually. So what we're doing here actually is, what we're creating a regular expression in NC field that's just pasting together these arguments. But what we're doing is we're using this first argument also for the name of whatever comes as after the second argument. The second argument is kind of a spacer that's not included in the capture grip. So if we do that, we get exactly the same result that we had above, but now the code is much cleaner because we avoided that repetition. So we can do the same thing with the chromosome here down here. So let's try that. NC field chromosome. And here the separator is colon tab rather than space like it was above. And here the thing to match is going to be everything until the end of the line. So let's see what happens when we use that instead of that. So here we get the same result again, but we've got some code that avoids the repetition, which is pretty nice. So that's pretty interesting. What can we do with that now? So now we can go back to our other files. Well, first of all, we've only matched some of the information in our info vec. If we recall what was in that info vec, we had, let's go all the way up to 50 this time. We have a bunch of other pieces of information other than the chromosome, right? We have number of sequences here, number of sites, number of discarded sites, processing, blah, 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 right? So all of these things you can extract using NC field if you want. So I'm not going to show you how to do all of that stuff right now. We're just going to focus on getting the chromosome and joining that to the data file. But you could imagine exercise for the reader, go through and create a regular expression that extracts all of this other stuff as well. Shouldn't be too hard. Now let's go back to our source, yeah. So let's save that data table and let's call it info.dt. That's gonna be our extracted version of info.vec. So let's do the same thing with the other data that we read, which was report.vec, right? Let's create a report.dt by applying capture all stir to report vec. So, let's recall that that data format again. Report vec. What does that look like? It looks like, it's kind of like CSV, but it's got these funny // headers which correspond to the alignment IDs. So to parse that out, basically we just have to use a regular expression like this, where we start with a double slash, then we read the rest of that line into the alignment. Maybe, yeah, it's maybe, it's an integer. We could be specific here. We can convert it to an integer. And then after that, we can maybe just parse the rest of that as CSV data. And the way we can do that is, well, basically what we want to do is we just want to keep going until we encounter the next slash. And that's what this regex says. It says match anything except for a slash and keep going. Match as many of them as you can. So let's see what happens when we run that. So report DT now. This is a data table with 10 rows corresponding to 10 different values of alignment, and one variable is not shown. The CSV variable is not shown because it's this long string with all of that CSV data. If you want to see what one of them looks like, report dt.csv1, well, I don't even know if I want to print it out, but let's just do it just for fun. That's what it looks like. So yeah, this is CSV data. So we can actually parse that with any CSV reader. And let's do that. So the recommended way to do that, my favorite way to parse CSV in R is using fread. So let's use data.table fread on that CSV data, and let's do that by every unique value of alignment. And what happens when we do that? Well, what happens is we get this data table that we wanted in the beginning, right? So we extract it out for every one of these values of alignment. We've got all of those, data from that report file as separate columns now, and we've got the alignment ID as another column. So let's call that, I don't know, report tall. And after that, the only step that remains to combine the data from the two files is to join them. So in data table, that's super easy. You do info.dt report.tall on, and here in the on clause, you just tell what is the variable name that you want to join on. And so the variable here that we want to join on is called alignment. And so let's call this, how about join dt, because this is the result of joining the two. And what does that look like? Join dt. Well, it looks like the same thing as what we had before, but instead of just the alignment, now we have the alignment and the corresponding chromosome, that scaffold that was present in the info file. Okay, so now we've gone from two files that were in kind of like loosely structured text format to one data table that is in a very structured CSV format. So thanks for listening, and I hope you learned something about how you can use NC and regular expressions to parse data from text to tabular format.